Hello everyone, welcome to the Breakfast Seminars. So before we begin, I'm going to give you a quick introduction of what we do here at ITRL. Our goal is to contribute to sustainable transport systems by looking at different mobility solutions, by exploring it through research and demonstrations so that they contribute somehow to reducing carbon emissions, being economically viable and socially acceptable. So in a nutshell, that's what we do here at ITRL, but we do a lot more, and you can look at our website for that. Next, we have Benjamin here today from Einride, who will be talking about his work with autonomous electric truck operations. But before he begins, I'm going to give you a quick agenda and some emergency information before Benjamin starts talking. No need to panic, it's information. We have the agenda here, so from now on till 40 minutes Benjamin will speak, then it's open for discussion for all of you for 15 minutes. And if you have more questions about what Einride does and what Benjamin does, you could open it up during the mingle sessions we have right after. For more information on the breakfast seminars and previous seminars, so we have about 21 seminars on there, you can go to our website and take a look and save the date for 26th of November. We have one more interesting one coming soon. And for emergency purposes, please follow the green signs on top of the doors, and the bathrooms are right downstairs. There are 2 on the basement. So, yeah, we should begin. Benjamin, welcome.
Thank you. Thank you, everyone. Great pleasure to be here and at the breakfast seminar. Got in touch with Albin, who contacted us quite a while ago on transport models and how to represent freight transport or autonomous freight transport in these models. And then we had a discussion, and I got invited to this session, which I am very happy about. So I'll let you know some more about Einride, but first I need to show you this awesome video. All right. So that was one of our trucks, and Einride was founded 2016 with a goal basically to make road freight transport sustainable. And the idea behind it still exists, luckily for us, and it basically means we combine autonomous and electric into one vehicle, which can deliver stuff and do operations in a much more sustainable and efficient way. But before I go into my talk, basically this talk is about how we prepare our company, but also outside our company, the world for autonomous electric transport operations, and under which conditions these are actually going to be more sustainable. So I will, in my presentation, go through 4 different agenda points. The first one is my motivation for autonomous electric transport. In general, I think this is a motivation that a lot of people share within the company, but also outside. It sounds very much like ITRL has similar ideas on how to approach these problems of basically impacting our planet very badly with too many CO2 emissions, especially in the transport sector. So I'll go back in time a little bit into my previous research and why I kind of started working for Einride. Welcome. First row. Then I'll talk a little bit about reaching sustainability with AT, autonomous electric trucks transport, how we aim to do that. I will go into some details around the operating system behind these trucks, not the single trucks. So I'm not going to talk so much about autonomous drive. I'm not going to talk so much about the vehicle itself, but more on a systems perspective. How we imagine it to operate. And finally, I will go into some regulatory aspects and what challenges we see there and where we think we need to partner up also and communicate a lot outside our company, of course. All right. I would suggest if there are any questions, if you directly don't understand something or you can't read something on a slide, please ask questions right away. Longer questions I would like to take in the end. Okay? So yeah, my motivation for autonomous electric transport. Well, I started my PhD in Berlin, Technical University in Berlin, around 2010. And basically what I was concerned about was environmental modeling and pricing. There was already, or there is still, a very sophisticated transport simulation toolkit, open source, called MatSim. It's an agent-based model. You can model, basically you model every person, like you, Alvin, you went up in the morning today, you had the plan to come to ITRL. So we model your activity at ITRL, we model your activity later at lunch or so. And in between these activities, you need to kind of transport yourself or make someone else transport you, move you around. And basically, this is what this formula says. You accumulate positive utility from acting. So, for instance, going to work or having a beer with your friends. And in between these activities, you have some negative utility that comes from traveling, right? You would like to reduce travel time, you would like to reduce costs for these. In the best case, you would like to beam, like go in no time from A to B potentially. Anyways, so this model was already there. And what I did was basically writing a plug-in to model tailpipe emissions of vehicles. So everything that comes out of the tailpipe was modeled and very detailed in that way that it was vehicle dependent. So each vehicle would have different magnitudes of emissions coming out, depending how big the vehicle is or how old and stuff. Plus, it would depend on the traffic pattern on each road segment, right? So in that sense, the resulting emissions are very individual to this vehicle at this point in time in this place. So this is just an aggregate picture of overall emissions, SO2 emissions in a case study in Munich. I mean, no big surprise. The ring roads are polluting. Yeah, wow. But the nice thing about it is that since we are modeling agents, we can basically calculate a toll based on the emissions they produce and force them to pay the equivalent money for their pollution. And then we have a behavioral model of these agents that then will react to this toll. So potentially they will change their travel behavior, for instance, going, if it's too expensive, maybe trying out public transport or going on a bike or something like that. Yes, so that's what we did, and this is, I mean, one motivation for me why I joined Einride was this here. Freight transport emissions in this scenario, at least, have a huge impact on overall emissions. I mean, the different colors here are only different types of emissions. In black is CO2. But overall, you can see all the passenger transport. I mean, it's maybe something like 50-50 roughly between freight and passenger transport in this particular scenario. So, so first of all, the overall impact of freight is big. And then we introduce different policies to the model. I mean, Munich also is like Stockholm, has roughly 1.5 million inhabitants plus the surroundings. So it's quite a lot of movements going on there. And calculating this toll for each individual and so on. So computation times get long. I think the simulation runs around, the longest one I have done is around a week on a big cluster. For this policy that I called internalization policy, which is basically a first best toll on each individual regarding, or which reflects their overall impact on emission levels. And so if we do this pricing, what we see is, okay, emissions go down between 2 and 4% or something like that. Only with the freight guys, not so much is happening. And why is that? Well, you can say maybe because we have a bad behavioral model for them, which is true because we only allowed them to change their routes, but mode of transports is also a little bit hard to justify why they cannot use public transport, obviously, and bike to a certain extent, but I mean, I think the overall thing, or the overall takeaway here is, if you don't give any alternatives to these guys, they only pay money and nothing's going to happen. So then I moved on to a research institute in Germany that is called German Aerospace Center. I never did anything with aerospace, though. They also have a big ground-based transportation research facility there. A lot, like you guys, with a lot of like actual hands-on stuff. Yeah. So basically, there I analyzed the effects of autonomous fleets. In particular, autonomous taxi fleets. Potential impacts, of course, because they're not there yet. So the system was called autonomous car sharing. I called it autonomous car sharing system, ACS, and basically pretty simple mode choice model behind it, depending on this is for all over Germany. Rural, suburban, urban areas in Germany, and our estimations are that this autonomous car sharing system could, with the prices we assumed, so the operator would break even, and waiting times dependent on demand and stuff like this, would roughly between 9 and 12% could be the market share of such a system at maturity. And, well, this is something, I'm not sure if these numbers are, of course, if they're correct or so, but by tendency you can see exactly the same thing with electric scooters right now. There is a new system coming in. All other modes lose market share. However, for the scooters, it doesn't look as good because it would probably take everything from walk, cycle, and public transport and just a little bit from the cars, right? That's at least the research I've read about it. But overall, we see this system takes demand, and all the other modes lose in that sense. And if we look at the vehicle kilometers travels on the road, which is on the very top, right here, if we look at that, we can see that it increases. So basically, car kilometers plus autonomous car sharing kilometers will be more than before the introduction of this car sharing system. What does that mean? More emissions, for sure. Also because you have some empty trips for these systems. More emissions and more congestion. So that was the point when I realized, well, these two things. The first one I already said, environmental pricing does not work unless there is an alternative. And the second one is vehicle automation will make things worse if not combined with renewable energy. It looks like very straightforward conclusions now. It took me a while to get there. But I still think they are valid. And the second one, especially the second one, made me to join Einride. If we look a little bit broader on, this is European Environmental Agency data for CO2 emissions in Europe since 1990. So this is the graph. And then we have a 2030 target, which is here. And then we have a 2050 target, which is, it's hard to see. It's so far down, which is here, right? So basically, this is not because we have been so great in improving the efficiency of our transport systems in terms of environmental impact. This is because of an economic crisis. And afterwards, it goes up again. So we observe 20% increase for road transport in CO2 emissions with respect to 1990 levels. And I mean, something needs to substantially change here. That is pretty clear. So how do we think we can contribute to this goal? I mean, I'm working with a team, really experienced researchers in the area of batteries, Christoph and Midi, and sustainability, cost analysis, all these kind of aspects we touch in our analysis. And one good thing, or why we think autonomous electric, or in this case especially electric trucks, can be some part of the solution, is the observed price for lithium-ion batteries, which is dropping substantially until today. And the forecasts, you never know, but there might be also another technological breakthrough in another technology. But overall, the price is going down. That's nice because it becomes competitive. And the other one, which is maybe even more important, is the energy density in the batteries. So in the battery packs per kilogram battery, you can store more energy, which makes the truck in the end lighter. And basically you can fill more stuff in it, or you have more range because you can, with the same battery. So we think in terms of electric. Why does this happen now and not 10 years ago? I think this is a strong argument for it. Onboard energy storage is available. There are some charging solutions I will talk about later on. So, but still, we have always we need to balance between weight and battery capacity still, right? Batteries are heavy, expensive, and so on. If we look at the Swedish freight market, though, in terms of transport performance, so ton kilometers moved around, there is a big chunk which is moved less than 100 kilometers. And even with 100 to 300 kilometers, I mean, this is of the overall transport volume, more than 3/3. So basically this is why our battery is at the moment roughly 250 kilowatt hours, which we think we can drive roughly 200 kilometers with. So this is kind of where this trade-off we think is going to be right now. This doesn't mean that this is going to be like this in the future, as I said, depending on the development in battery technology. But there is already something to move for us. So electric, I've now said why we think it's cost-wise a good idea. Autonomous, well, there has been a big development in computing power. Sensors are getting better and better. So basically, this is something we can, at least in the next upcoming years, this will reach a maturity that you can actually industrialize. And the important part why we are going autonomous and electric, I mean, one thing I said already is, if you only go autonomous with diesel trucks, things will eventually get worse. But we also think that this fusion between autonomous and electric we can have charging times that are way less costly. So you just park the truck, you don't have to pay a driver while it's charging. So charging times get way less costly. Slow charging, we can slow charge the batteries, which is extremely important when you want to reach sustainability, because fast charging a battery will potentially halven the cycle length, so the number of times you can actually recharge it. So in terms of environmental footprint, the slow charging is extremely important, which you can't do when you have a driver on board. I mean, I don't know, maybe some of you have seen the Tesla huge battery electric truck that they have, and there, I mean, this is just so much money when there's a driver plus this truck standing around, and then they want to fast charge it. It's completely unresolved how a charging station for this would need to be dimensioned, like without blowing up the whole truck. So cost competitive transport solution, we think we can get there and it will be a fusion of autonomous and electric. It needs to be a fusion in a way. Yeah, so that's basically our take why this is happening right now. If we look at the cost components, this is roughly what we might be a little bit too much now, but I'm not going to go into details. Overall, when we calculate stuff, we have total cost of operations. That is an indicator for how competitive are we to compare to other solutions. And what we estimate is, I think, yeah, you can't really see it. This turned green, I have to say it. Fuel energy costs are going down. That's our estimate when we move from from electric to towards electric from diesel. And this is so there we see some cost cuts. We see some cost cuts at the operator side, because we think that I think you have a remote driver station here out here, right? And I saw there was someone talking about it in the last session here. He's here. Hi. So I'm really interested to see that remote driver station maybe later, or at least get a little introduction to it. That would be awesome. But of course we also do this kind of stuff. So we're estimating that we can reach a certain level of drivers to, like, ratio drivers to vehicles. Also in very simple applications in the beginning maybe. So yeah, but operator costs will go down. That's the promise of automation, right? When we talk about acquisition, it's not as clear cut. There is, of course, additional investment, like you need to buy lidars, you need to buy all these computers. Potentially they're outdated after some time, and so on and so on. On the other hand, we don't have a driver cap. Driver caps are roughly half of the costs of a truck. So there is some balancing going on here, where this is not fully resolved. There are a lot of aspects to it. So acquisition costs could go either way. Depends a little bit on on how this goes on the hardware side, especially. Yes. So overall, we estimate total operation costs to go down. This needs to happen, and we think that there is a business case for it. If there is a business case for it, this will happen automagically. If we look at the cost breakdown of an manually driven diesel truck versus an autonomous electric transport truck or so, then what you can see here is basically, first of all, the manual driven truck has a higher cost of operations than the one we estimate for our system. Interestingly, here on the percentage split is that you have labor and fuel costs as almost 70% of the overall costs of a truck of truck operations here. And here for the AT system, this is much more balanced, right? So this means in the end we can work a lot more on the hardware part, depreciation to bring these costs down. We can work, of course, on the labor and fuel side with optimization, system optimization, to reduce those. Plus, there is, of course, the ability of these systems to operate longer times per day, right? We estimate something around maybe 16, 17 hours operations per day, which is normally manual driven diesel truck has around 8 to 10 hours operations. Of course, if you can shift drivers and so on, that can be increased also, but then you need to have a really special use case. So when we look at CO2 emissions, I mean, that's the ultimate goal, reducing them. Then we need to look at the production of batteries, and we need to look at operations. So if we look at the production of batteries, this shows what the battery footprint is of a battery produced in these countries with the current electricity mix. So I guess Sweden, France, nuclear plus hydro is pretty good. Germany, China, a lot of coal, pretty bad. So the vehicle will come with basically a backpack of CO2 on the market, and then needs to run in order to get rid of this backpack. So at a certain kilometer range, this backpack will be gone, and then everything beyond that is benefit. If we look at these operational CO2 emissions, and I've plotted the diesel truck here and made a straight line, green line, and these are all the countries, or I think almost all the countries in Europe. Then you can see, I mean, all the countries under this green line, there is a environmental case, pretty strong environmental case. Even for the EU 28 average, there is a case. This is, I think, a very important point to make here. Of course, there are some countries where it doesn't work. This might seem a little bit big on this slide because I don't think Gibraltar is going to make the difference. But maybe, I mean, for sure, United Kingdom and Germany need to make a move in order to get this right. So we see ourselves on a basically parallel track to a necessary transition towards renewables. This is, I plotted this graph for 2011, and the nice thing is, at least, some countries went under the green bar. Yeah. So there is some development, and I think in Germany, for instance, there are really a lot of discussions increasing the energy mix. I mean, we went out of nuclear after Fukushima, which obviously increases then coal-powered stuff. But in the same time, also over the last 15 years, we have increased quite a bit. I think 40% is in renewables right now, which is pretty much. And I think that it came from like 10% or under 10% 10, 15 years ago. Yes, so now I need to check the time. Crafting the operating system for such a transportation system is not easy, and I'm happy to have a lot of skilled colleagues as well to help me there. But basically, as you can probably imagine, it's more about just telling one truck what to do. It's about the big benefits come when you plan it when you centrally plan it as a system. So basically, what we're doing is one of the things we're doing is solving the vehicle routing problem. And the vehicle routing problem is a pretty old problem in operations research. Basically, given you have, in this case, a pickup point and several delivery points, and you want to assign the packages or the shipments to trucks and plan the routes in an optimal way, cost minimal way in the end, right? So minimize total system costs is basically the objective function. And input is what vehicles are we using, what are their loading capacities, how long can we drive, what is the demand, which time windows do we need to consider, when do customers want to have their stuff delivered, travel times and distance between the locations. They can also, of course, be impacted by time of day and the demand, normal traffic jams and stuff like that. And cost model, I presented a little bit about that. And so this is pretty well-known problem. However, for electric vehicles, this is pretty much research. As you can imagine, maybe electric vehicles, because they need to charge and because they have a different, and this is, for instance, a graph of energy state of charge for our vehicle driving up 10 kilometers uphill and then 10 kilometers downhill. So it actually regains energy. And there's a drive cycle behind it. That's why it's not like linear. But basically, what we're saying is the energy consumption and prediction models need to be a lot more accurate than for diesel, because you need to plan charging. So energy consumption models, charger locations and capacities, the output, what can we actually get from the grid, to which price is a input normally. Charger locations we can discuss, could be also part of the optimization. And we have that developed. And so basically what we can do is calculate some plans for the vehicles, pick something up in Gothenburg, go to Jönköping, drop off stuff, then charge there, drop off at another location, and so on. So we actually calculate for the whole fleet of vehicles different, like the plans for each vehicle that minimize operational costs. So since this is also an academic problem, the question is always, is it enough to solve academic instances or problems that you have made up that you know the optimal solution for? In this case, for instance, this is the same problem, only that this one here has a lot more rigid time windows, right? So you need, in this case, you need 2 trucks, and here you need 3 trucks, because you cannot deliver at the same point, at different points with the same truck at the same time. So also a very famous academic problem here. The problem with these problems is that they don't reflect reality. So what we're doing is we look at networks of our customers. and trying to really understand their operations and how they do it today, or we optimize for the diesel case. Then we plug in an autonomous electric transport systems where you then see, oh, without charging, I won't be able to reach most of my customers. Yeah. So then we put some charging in, and we see, okay, we can reach the customers, but this system is not going to look like this system. So this is a misconception often that people think, oh, we just take out this diesel truck and put 2 electric autonomous vehicles in there, and then it's done. No, it's not like that. The network will look different, and you need to rethink the whole system. Of course, you could also think about different fleet mixes, for instance, like some are done by diesel, others by our pods, and so on and so on. So this is very interesting research. Okay, yeah. Well, when we go into real-world operations, I mean, we can produce all these. I mean, these are the plans basically of all the pods in this case: driving, waiting, delivery, pickup, charging. So we can kind of schedule them. We can observe the state of charge of the vehicles and the fill rate and all sorts of stuff is available, of course, and needs to be also fed back from the real world once we're in operations in order to compare and dynamically re-optimize. Okay, so I have a few more minutes for regulatory challenges that we see or that we're facing when deploying these autonomous electric transport systems. And the first one is about automated charging. I mean, automated charging seems to be important, at least to think about it when you roll out such a system. Mainly because there needs to be some optimization going on. I mean, you probably there will be no infrastructure where all the demand fits, right? So there might be some booking system if it's not private, of course, but if it's somehow public infrastructure as well. There needs to be some scheduling, some smart scheduling, and also we need to consider, of course, the capability of the grids, right? If we send, I don't know, 10 T-pods to ITRL and plug them into the electricity plug, it might be that you cannot handle it here with your electricity network. So it's really important to take into consideration these kind of aspects as well. Another one is, of course, about autonomous driving. People often ask, so when are you going to drive? Yeah, well, we are driving already for DB Schenker in Jönköping. And there is even a stretch of public road in this flow. It's limited, but it's a very nice use case where we can say we have the dialogue with the authorities, Transportstyrelsen here in Sweden, where we can actually work on a permit basis. So we're not trying to solve the problem, go downtown Stockholm and deliver to 55 shops. Because that's not, I think Transportstyrelsen would say, maybe at the moment, not yet. So we're trying to do our rollout really from simple to complex with the maturity of our company, with the maturity of all our development. And I think this is working pretty nicely so far. So autonomous driving is of course a key enabler, as I said, to get sustainable. But we think that we're on the right track regarding this. Next thing, connectivity, which is often kind of put into the same shelf as safety, because if you don't have a driver in the car, but you have a remote drive station, for instance, to supervise the cars. You need to have connectivity, of course. However, our approach there is that we always have, like even if connectivity completely stops, the car is able to have a safety maneuver to bring itself into a safe state. And that must be guaranteed, because no one can guarantee 100% uptime for this. So 5G is, of course, we think important for the rollout of our system. It's I think we need it, and there are discussions going on about like how is it deployed? Is it deployed more for private usage or more for industrial usages, and so on and so on. Overall, I would say the focus in the beginning, because the biggest benefits are in the industrialization or in the industrial part. Also because for safety critical functions, I don't know how much you know about this 5G, but apparently you can slice the bandwidth, and you can guarantee a part of the bandwidth to a certain user. And for safety critical reasons, we think, or functions, this needs to be guaranteed that this is that it's possible to slice this into these. And car-to-car communication can also impact safety, so we think there needs to be a good channel for this as well. All right, I think this was it from my side. I'm pretty much on time, I think, and I'm really looking forward to a fruitful discussion with you guys. Thank you.
I didn't really understand how exactly you calculated the CO2 emissions for the battery side, because you showed this graph with the, if you can maybe go back to the slide. Yeah. I mean, I didn't really understand. Is that the production of the battery?
Yes.
Okay, because I've done like a similar research, and I mean, I found much bigger numbers.
Okay.
But I don't understand. Did you like just estimate how much energy you need to have a 1 kilowatt hour capacity battery, and then you said, okay, it's produced in Sweden, so this is how much it's going to take?
It's the energy usage. Some details are in here, so you can have a look. But I would be interested if you have. That's not my field of expertise. That's Christoph. But maybe we can check that, because I would be, of course, interested in.
Yeah, and the other graph is just like, okay, you say for 1 kilometer I have this emissions with the truck, and that's the green line, right? And then the other one is just, okay, I need to charge this much to have 1 kilometer in this country. Is that correct? Okay, then I got it. Thanks.
Yeah. So basically, the difference here is the benefit of an electric car compared to the. Yeah.
Okay.
What does your cost function look like? The optimization problem which you solved?
Well, I mean, like this, roughly.
You showed us the input constraints and different travel times which you need to meet up, and then did you also include emissions in the cost function?
Well, the emissions are coming from here. So operational emissions are coming from fuel usage. So basically, you need to. I mean, if you look at a diesel truck, you need to refuel it depending on the energy used on that route that you assign to it, right? And for an electric truck, similar. The model is just more complex, and so basically the energy usage will be an output of the optimization. But of course, if, for instance, a customer or so has a strong preference, we want to be sustainable, and not only minimizing cost, you could give a weight to this in the optimization. so that this would get a bigger impact on the trade-off between other cost factors.
Was it a convex function?
Actually, I don't know. I haven't plotted it. I need to think about it. We can go into some details, but I don't have it on the top of my head now how it looks like.
Coming back to the CO2 emissions, you talked about this backpack, and you have some need a certain distance driven with your truck to have the battery production emissions paid back, so to speak.
This one. Yeah.
Can you give any indication of what is this distance for a few different countries? Like
I think disclaimer. I have to remember. I think we did this for Sweden, which is a very, very favorable case, of course. But you need to drive over lifetime 10,000 kilometers a year with the truck, which is not much. But of course, when we get closer to the green line, that will be more, of course. Yeah.
So you're focusing on battery electric vehicles, but have you also looked at electric road systems?
Mm-hmm.
And why is battery electric the focus, or why not the other? Yeah.
I mean, the main reason for battery electric at this point in time, all these road systems. There's a lot of talk. I've been to Lund University. They are kind of pushing this rail thingy. In Germany, they're doing the over the truck kind of electricity stuff. But overall, everything I've seen that seems reasonable there means you would equip a certain part of the network with these systems and not the whole network, which means you still need batteries. They can be smaller, which we would appreciate a lot because it would be cheaper. So I don't have any, we don't have anything against these systems, but at the moment, in order to get started, it doesn't seem like it will be there in the next years. So, but that doesn't mean that will be our idea for the next 20 years or so. If this is evolving, and we might very well jump on that.
Yes, a question on more or less the same topic. You have your truck today, but if you go out and look at the transport systems today in Europe, you have to move a semi-trailer.
Yes.
You can't move a semi-trailer with your truck. Your thoughts about that?
Well, with this truck we can only do basically like we can put a trailer behind, not a semi-trailer though. But of course we're looking into different product differentiations around that. There is also some like various customers have different needs there. This truck is basically the one where we think it can fit quite a few use cases. But of course, the more when we grow and with our customers, there will be most likely different hardware available. Yeah.
So about a non-CO2 question about your operations. I think the traffic regulatory slide towards the end. Are you dependent on 5G for your work, or how does your
This one?
Well, the next one, I guess.
This is 5G.
Basically,
Okay, yeah,
how to
just.
drive on public roads, right?
Mhm.
And you said you have some supervision,
Mhm.
but you don't have a cab, so the supervision is remote, I suppose,
Mhm.
over 5G.
Mhm.
And so 5G is essential for you to move.
No, it's not.
No.
It's not. We're testing. We're using 4G and 5G. We have kind of both set up for our tests and for our operations. So it's possible in a limited environment, but we still think that we want to push this development still, because we think the pure scale of vehicles at some point will make it necessary, but it's not a limiting factor right now.
But slicing, for example, is limited to 5G, right?
Yeah, exactly. That's what I say. Like if you scale up the fleet, at some point we might need 5G, right? But at the moment we are not limited by the, I mean we are not bound or like the company is not dependent on 5G at the moment. But once we scale up, this will be essential at some point.
What speed do you drive on the public road?
Not 100% sure actually. Very very slow. Something like 7 kilometers an hour or so. Which is part of the safety aspects. The vehicle can go a lot faster, but we're not allowed to at the moment. But we're working on that, of course.
Another question, but regarding the operations in loading and unloading, for instance, all these things that the driver usually participates in today and that you can solve with a remote operator. Can you say something about what these pilots have done? How big of a threshold has those parts been? Is that a major challenge, or is it just something that will be solved? What do you think?
So not having a driver obviously means that the overall logistic systems at the customers needs to be upgraded to a certain extent. So the driver cannot do certain tasks. However, what we see from the customer side is that they're willing to take some of this workload into the warehouse, for instance. So there will be a lot of, in the beginning it won't be, we don't rely on automated loading and unloading stuff. This is just, I mean, also needs development time, and we might buy in that and stuff like this. So basically the idea is to use the existing personnel and have a very smooth interaction between the truck and that personnel.
So you're basically shifting the workload and cost from the truck driver to the logistics.
Yes, even though, I mean, it depends a little bit how it's done today. There is sometimes slack in the system where anyways someone needs to be at the dock. So it's use case specific, I think, in terms of how much additional cost that is. But yeah, there is some need to kind of bring these systems on a different level in terms of how do you communicate your stuff is arriving now, someone needs to be there, and so on and so on.
What's the main obstacle for that massive rollout of Einride? Technology, regulation, market maturity?
Good question. I don't know if I have the answer to that. I think, I mean, to a certain extent, regulatory frameworks, if we wanna be on public road, is a kind of can be a blocker. Not necessarily. Depends. For instance, in many states in the U.S., there are very open legislation around this. So it depends there very much geographically. And we also think that we have actually also used a lot of use cases that could be that are just completely fenced off. So where we can basically do not what we want, but what our customer wants us to do, right? So I think regulatory stuff is one thing. The other one, I think, is maturity of autonomous drive. Like, and there, that depends very much with the regulatory framework or interacts a lot, because if we can prove certain things, then it will be allowed to drive on public roads, right? Yeah. So hardware, I think, is not a big issue for us. I mean, the industrialization of a truck is, of course, a big topic, but it's not like we are bound to that. We can also, I mean, we're using partners obviously for this. It's not us producing the trucks. So I think there on that side, I'm more confident. Yeah. So I think it will be a gradual gradual thing. And in the meantime, we can lead with the software products that we have that are also applicable to current fleets.
A very cool new platform is very shiny and it works, and you are in operation now. But what do you think is your biggest advantage compared to the competitors in the field? Many people are working towards electrification and autonomy.
Yeah, it's always hard to say who is actually a competitor. I mean, there are a lot of software platforms out there. I would say we have the advantage of having the full stack and the full control. So we do really end to end, and that is in some way a uniqueness, I would say, in the trucking industry at least. There's a lot about, of course, retrofitting, especially in the truck industry, retrofitting diesel trucks and making them autonomous, right? Quite a few bigger startups are working on that. I think that the environmental momentum will gain importance. So I see that the sustainability edge that we have is crucial for, or is differentiating us from our competitors.
So you don't see that a problem like Volvo Vera or like Scania Axle, they are not competitors?
If they are direct competitors or not, that I don't know. We have a few insights into what they're doing. And I think it's good for the market that they're pushing there as well.
Okay, one last question. Okay, so I'll encourage you guys to ask more about what Einride is doing. Benjamin, and stick around and grab more coffee and stay here.
Thank you very much.
Just a reminder before you all leave, go back again to the ITRL events and please look for the previous seminars and also keep a lookout for the next couple of seminars coming up.
26th of November.
Yes.